I received a piece of paper that says that I can count good. Have you ever actually seen what's in one of these things? Yeah. I can't make this shit up. What do they teach you in mechanical engineering? Because I feel like a lot of people, they just think that it's impossible and that it's just a bunch of math and physics. And don't get me wrong, it's a lot of math and physics, but that's not all that it is. If I've asked you to name one class in engineering, what would you say? If you said calculus, you're wrong, because that's just a prerequisite class. But we're gonna go through all of it, the entire major.
In the beginning.
Statics. I've got to make a contraption for this one. In front of me, I have a statics problem. In statics, the one thing that you learn is all of the forces in the X and Y directions need to equal each other. If I'm pressing down here, it has to be supported by here and here. Exercise for the viewer. How much force is getting supported on this and how much force is getting supported on this compared to this? Half, exactly. See, guy is smart, just like you, dear viewer. That sounds awfully easy for an entire course. Well, you gotta do it in different directions too, using trigonometry. But don't panic, you can use your calculator on the exam. We'll get to why that's a bad thing later. You also have to do it in 3 dimensions. We did it a 2-dimensional example because I'm trapped in your screen and, I can't get out. We don't need any of this anymore. Dynamics is the next course after statics, and it's the Pokemon evolution of it. Now you're doing the same thing where you're balancing forces, but everything is moving now. If you ever took a physics class, you are familiar with the Newton's equations of motion. You do that and the static shit. Differential equations is next, and that's the last math course you ever really have to take. Differential equations is solving problems that have integrals and derivatives inside of it that have to stay there. Learning how to do the math that is used in the rest of engineering. It's not as hard as Calc 2. It's not even probably as hard as Calc 1 the way that I took it. I had a really easy professor. That's differential equations. Don't get scared. Structures and properties of materials is a class about half chemistry. It's about fracture mechanics. Why are things solids and liquids, and what are the differences between them? We're at the end of the first year. Congratulations. You have made it to being a sophomore in engineering. It gets harder now. The first class that we're going to talk about is probably the hardest until you get to your last year, which is thermodynamics. Thermodynamics is usually split up into thermo 1 and 2, but at my college, it wasn't. To do math problems, you need to learn what the numbers are before you can actually work with them. To do engineering problems, you need to learn about the properties of substances. An example of this would be like the boiling point of a substance. You learn about all of them. Earlier, I mentioned that we generally think of engineering as math and physics, but I think a more accurate description is solid mechanics and energy mechanics. Solid mechanics is what we've already talked about, which is statics and dynamics. It's balancing forces in different directions to solve for the missing one. Energy mechanics is solving for missing property substances that can help us solve real problems, like how hot is it inside of the shed right now? Well, you need the properties of air to figure that out. That would be a problem that you could do with thermo. Am I making sense so far? Okay, good. Principles of electrical engineering. This is a really weird one. I would think of the rest of engineering as mechanics problem solving, but principles of electrical engineering is like puzzle solving. You're simplifying circuit diagrams, medium difficulty. Solid mechanics is statics 2. When will something actually break? Because if you solve a problem in statics, congratulations, you've got a number that says how hard you're pushing on something. But that's not really useful. For example, if I was pushing really hard on this table, I could figure out with statics how hard I'm pushing on it. But I can figure out with solid mechanics when the table's gonna break, and you can see how that's a little bit more useful in engineering. Probability and statistics for engineers, God, I hated that class. It was all online and it was hella boring. It's literally just statistics. I don't know why they tacked on 4 engineers to the end of it. It's just to make us feel important. Now we're into the 3rd year. God damn, we're moving fast. Modeling methods in mechanical engineering. Modeling methods is really interesting because it's a class about solving impossible problems. Sometimes a problem is simply too big to solve it with regular math. Modeling methods teaches you methods to kind of sort of get the right answer if the problem is too big and hard. Modeling methods is also where you learn MATLAB. MATLAB is a programming language that is actually a calculator disguised as a programming language. Next, we got fluid mechanics, which is the continuation of thermo, but it's a lot more specific. Fluids was not trivial for me because the professor, he was very fair, but he was also very thorough. We had to learn a lot of fluids in order to pass this class. Oh yeah, this but I can't say his name in the recording. Yeah. We'll fix it. I'll fix that in post. What do you mean we? I'm editing this video. Another thing that I will say about fluid mechanics, the math in it is perhaps harder than everything else in the major except for one thing, which we'll get to very soon. Fluid mechanics is a lot of three-dimensional approximate math. We don't really have exact solutions to all of the fluids problems yet because they're really complicated. Fluids are unpredictable, and we don't have computers good enough to get real solutions to every single problem. The kind of sort of solutions from modeling methods really come up a whole lot. Mechanical engineering measurements. Measurements is a combination of every single class in engineering that you have taken thus far, except you're doing experiments on them. Now you're taking what you've learned and applying it to a real world problem in front of you. Sounds really interesting. However, there's some drawbacks. One, it's a lot of report writing. It's not that bad because a lot of them are diagrams, but it's still 400 pages of report writing. The other caveat is it's a lot of statistics. We're on design and analysis of machine components, which is the next evolution in the statics, dynamics, solid mechanics tree. It is about why materials fail and how to calculate it, and why picking a different material for a different task is really important. Up to this point, we've been dealing in Cartesian coordinates, which is just like straight stuff. In design and analysis of machine components, you're dealing with like screws and crankshafts, which are rotational stuff. When does something break is the most important question that I've used in my day-to-day life in engineering. I learned that in this class.
How do you learn when a heart breaks?
Engineers don't talk to women. Next, we've got heat transfer, which is the next in the energy mechanics after fluid mechanics. Fluid mechanics, I did not enjoy. Heat transfer 1 was my favorite class in engineering. Not only is it like 4 out of 10 difficulty compared to like thermo and fluids, which I'd say are both 8 or 9 out of 10 difficulty, it's structured out super well. In the normal class, you'll have 8 or 9 chapters, not heat transfer. In heat transfer, there's 3 chapters. The normal one, the hard one, and the weird one. The normal one's conduction. It's solid on solid heat transfer. The hard one is convection. Goddamn, I hope you were paying attention in fluid mechanics. When a fluid interacts with a solid, that is convection. You may have heard of a convection oven. The fluid in a convection oven is air. In fluids and in heat transfer, you learn about the difference between laminar and turbulent and why that's a huge freaking deal. Radiation is weird because it's literal magic. Like, you don't need a medium to transfer heat. That doesn't make any goddamn sense. Oh, we've arrived at the hardest class. Introductions to vibrations and controls. This class was so hard that they have now split it up. Vibrations and controls is actually 2 classes in 1 class. The first half of the semester is vibrations. The second half is controls. They don't do that anymore. You get an entire semester for vibrations and an entire semester for controls, and you choose one or the other. What makes vibrations so hard? Well, this is the final boss of your solid mechanics track. Boyoyoing is the worst way that a thing can move. Why? It's super unpredictable, really difficult math, and it's a whole lot of grinding work. Controls engineering is more about like, let me think of an example. A thermostat. If you set your thermostat to 70 degrees, your AC unit can only be on or off. The AC does not go on until your house reaches a temperature of 75 degrees. This is 70, this is 75. Then the AC turns on until you're at 65 degrees, then it turns off until you're back at 75. And you're kind of feel like it's 70 degrees, but in reality, it's not. The entire job of a controls engineer is to figure out how big this range should be. Should it be 65 and 70 or maybe like 68 and 72? It's also to make sure that you never notice that it's happening. Another example is cruise control. That's it for the engineering courses that everybody has to take. Now you do optional ones. You get to pick from a list of 5 courses that are restricted electives and 2 courses that are lab electives. You have to pick one of these and 2 of these. Does that make sense? Okay, cool. These restricted electives are, they're going to sound real familiar. Heat transfer 2, intermediate systems dynamics and controls, vibrations 2, fluid mechanics 2, thermodynamics of mechanical systems, thermodynamics 2, design and analysis of machine components 2. Lucky for you, dear viewer, I was only required to take 2 of these courses, but I took 3 of them. I did not take intermediate vibrations and controls. That's horrifying. I also did not take thermodynamics 2. I mean, I didn't have a good time in thermo 1 because my professor was he was a physicist, and physicists do not teach like engineering professors do. Despite getting an A in vibrations 1, the pass rate of vibrations 2 was not doing so good, so I just kind of assumed that the class was being taught poorly. Judging from the fact that the department kind of split them up, I guess I was right. What I did take was heat transfer 2. Heat transfer 2 takes everything that you learned in heat transfer 1 and builds upon it. Problems that are dependent on time. Boiling was a big one in heat transfer 2. How much heat is in the system at 1 second? How much heat is in the system at 10 seconds? Fluid mechanics 2. That class was so difficult that I blacked out through it. I don't remember a single thing. open note exams, not a fun time. Design and analysis of machine components 2, it's only 2 chapters. The first half of the semester is gears. What material can you pick that will not let the gear break if it's running for this many cycles? You know, the second half of design and analysis of machine components 2 was finite element analysis, which is just vibrations with extra steps. You remember in principles in electrical engineering when I said that modeling things as circuit diagrams was really important for other things? Finite element analysis is modeling suspension systems as circuit diagrams, simplifying them, plugging it into a calculator, and it's spitting out the right answer. When there's 9 springs in a system, that makes a 9x9 matrix, which is 3 pages of work. Anyway, the one of 2 lab courses. You can either pick from mechanical systems or energy systems. If you pick mechanical systems, you will be doing a lot of solid mechanics track work. You remember how I talked about the solid mechanics track and the energy track? This is the culmination of that mentality. So if you enjoyed the solid mechanics stuff, you're going to pick mechanical systems lab. It's a laboratory course just like measurements. That's my understanding. I didn't take it. I took energy systems because I thought I was going to be an HVAC engineer. And I guess in a way I still kind of am. Energy systems was dramatically more difficult than the dynamics course. The material in energy systems is a lot of the weird stuff in engineering, heat transfer of fluids, and electrical engineering. All right, last is you get to choose from a list of 40 classes, and I picked HVAC engineering. In HVAC engineering, you learn how to model a house. I also picked, what was the other one? Intro to robotics. It's exactly what it sounds like. The lab was really cool. We got to play with those Boston Dynamics dogs. That was awesome. It's a big history class, but like in a good way. The textbook was actually really interesting. The last 2 technical electives that I took, it was computer aided design and Introduction to, what was it called? Introduction to Design Engineering, the CAD 2 class. Computer aided design, or CAD, is 3D modeling, and I am exceptionally good at 3D modeling. I love it. In CAD class, you learn about how to model problems to test them in real life that we can't realistically build to test. You can't just build an engine to blow it up unless you're like SpaceX or something. In Intro to Engineering Design, whatever it was freaking called, it's more of the same thing. You do a little bit more advanced CAD stuff, but it's more project-based and open-ended. For the second half of the semester, you design a product to be manufactured at a mass scale, and it has to solve an engineering problem in the real world. Future video about what I did on that, because I think it's pretty cool. And that's engineering. We did it. We got through all of the classes, except senior design. It's essentially a 2-semester-long group project. In 5 months, we're going to release a video on it, so I won't get too into what I did, but I'll tell you what happened. In the first semester of senior design, you are sat down in a lecture hall with every other engineer in your major. For me, it was like 400 or 500 students. You were then presented one after another with 30 or 40 projects. There is this thing called ABET accreditation, which is a company that goes around to different colleges to see if they're good enough to give people diplomas. Notably, the requirements for a senior design project by ABET for mechanical engineering, it has to move. You know, that's not a whole lot of requirements. The requirements, however, for the aerospace projects are... This is all to say that the aerospace projects are significantly more difficult than the mechanical ones. In the first half of that entire semester, you do a lot of CAD modeling, you do a lot of simulations, you do a lot of report writing. The final report for that semester was, I think, 170 or so pages. It's not so bad. Actually, I enjoyed Senior Design 1. I'm really good at report writing, so I didn't give a shit. Senior Design 2 is where it gets real interesting, because now you got to put your money where your mouth is. Literally. The school gives you money, and you need to build the thing, and it has to work. If you pick a harder project, you get more leeway, I think, in how good your project works. There are some projects that have yet to be completed. My project was a brand new one. I barely got it to work. It was really hard. We did it. We did the whole major. That's all of it. Now we're going to go over the hardest ones. Third hardest was energy systems. Energy systems combined all of the other hardest classes into one class, and it dumbed it down a little bit, but it was still just such a wide expanse breadth of information that you had to know for one exam. Second hardest was introductions to vibrations and controls. There's no way around it. That class is just hard. When you have like a mid professor and it's that hard of a class, you're going to have a really tough time because you have to teach yourself way more. The hardest class, though, There is no contest. It was thermodynamics. Here's the thing, all right? We need to talk about professors at length for a little bit. Rate my professor is horseshit. I can actually prove it. If you look up, like, the professors that teach the ending classes of engineering, like the senior year ones, their ratings are a lot higher than the ones in the beginning of the year. This isn't because they're better professors, it's because of survivor bias. The students that rate professors badly are just lazy, and they failed out of the major by the time that they got to the end of it. So, for that reason, the professors in the second half of the major are rated way higher. That being said, thermodynamics was a different story. I remember the third exam that I took with him, none of the above was the answer for 5 questions in a row. His final exam, I was in there for 4 hours and 15 minutes, and the class average was a 30. Oof. That's low.
Out of 30?
No, out of 100. I had an A going into that final exam, and I needed a 12 to pass, and I got a 14 on that exam. The exam scores were so bad that 3 weeks after the grades closed, he offered a retake. By the way, that 30 average was the first exam and the second exam averaged together. So you can see how that went. Here's the thing about engineering, right? If your professor gives you more things to take to the exam with you, they're allowed to make it harder. For example, if they let you use a calculator, they're allowed to put math on the test that can only be done with a calculator. If you are allowed a textbook, like in thermodynamics, where you need all of the properties of different materials from a table, well, now the professor has to let you take the textbook into the exam, so that exam's gonna get a lot harder really fast. My thermo professor let you take whatever you want to the exam. That exam was impossible. Thermodynamics is the end of second year, and that was by far the hardest exam that I ever took, and it's not even close. Anyway, enough about thermo. How do you succeed in engineering? Engineering is not really about being talented or intelligent as much as it is about being able to endure throwing yourself at a math problem. How do you do that? Caffeine. It's fun, man. Senior design is a trip. In the middle of engineering, it just feels like you're solving math problems and not really doing anything. It's important to remember why you're doing it, you know? You're doing it to build cool shit. And I can say, without a doubt, we're building some cool shit this summer. I'll see you next week when I attach an engine to 15,000 RPM of fan blades.